Pro Electrician number 5. Shown on the screen is the section from the previous Pro Electrician number 4 using the NEC. The answers are shown on the right side. Do go through the NEC on your own, the 2011 or later version, and look for these answers on your own so you become familiar using the NEC. Being familiar with the NEC is very critical to the understanding and the success in this course. This is Chapter 5, Wiring Methods. The technical terms for this chapter are shown on the screen, and the objectives for the chapter are also shown on the screen. This chapter is an introduction to conduits, raceways, busways, wireways, junction boxes, gutters, busbars, pull boxes, device boxes, and a host of other wiring methods and related components. These items compose the system through which electricity is routed. The code recognizes many wiring methods for use in buildings. These wiring methods fall into several main categories, some of which are shown on the screen: raceways, conductors, cable trays, busways, gutters, and wireways. Some of the wiring methods have very specific applications, while others can be used in a greater variety of conditions. The table shown on the screen lists wiring methods and their corresponding code articles. This is not a complete list of all wiring methods approved in the code. The reader is encouraged to look into all methods of wiring and techniques covered in the code. General rules and requirements. The code under Article 300, Wiring Methods, addresses the acceptable methods of installing conductors. Choosing the right method of a wiring job depends on the environment where the wiring is to be installed. Certain wiring methods are only permitted in a limited range of conditions. Others are acceptable in a broad variety of situations. Again, when we talk about environment, we're not only talking about temperature, but also atmospheric environment or conditions such as flammable, gaseous, dusty, corrosive, wet, damp, etc. Regardless of the specific wiring method, there are general rules common to many of the methods. These provisions should be understood before beginning any wiring installation. A brief look at these general provisions follows. Just to read the warning before that: conductors placed in service where the voltage or temperature may exceed the specific rating will represent a serious hazard to the electrical system, equipment, structure, and personnel. And some of the general rules are first, whether in cable or a single individual units, conductors should be used within the voltage and temperature range for which they are designed. Normally, this is the second one, normally single conductors may only be installed as part of a wiring method recognized by the code. Thus, routing individual conductors without the protection of or support of an approved wiring method is strictly prohibited. And third, for a circuit, the current carrying conductors, neutral conductor or used, and equipment grounding conductor must all be run within the same conduit, cable, duct, tray, or enclosure. Failure to comply with these requirements could lead to inductance problems. NEC Notes 300.3b shown on the screen, all conductors of the same circuit, and where used, the grounding conductor or grounded conductor, and all equipment grounding conductors shall be contained within the same raceway, cable, tray, trench, cable, or cord. See exceptions in the code. A fourth general rule is that circuits of different voltage may be run in the same raceway or occupy the same spaces, enclosures, equipment, providing that the voltage is less than 600 volts and the conductors each have installation ratings greater than or equal to that of the circuits with the highest voltage rating. For example, conductors rated for 300 volts can be run in the same raceway as conductors rated for 600 volts as long as the maximum circuit voltage is 300 volts. And fourth, measures must be taken to protect conductors against physical damage. When running cable through bored holes in framing members, the edge of the hole should be 1 1/4 inch away from the nearest edge of the member. If a cable or raceway is placed along notches made of wood framing members, the notches must be protected from nails and screws by using a metal plate, minimum of 1/16 inch thick to cover the notches. If cables or non-metallic raceway is run perpendicular to exposed studs, rafters, or joists and subject to damage, strips of 1x1 or 1x2 wood stock should be placed along either side to protect the wiring from damage. For this, see figure 5-2. Before we see that figure, we'll read notes NEC Note 300.5 D4, where the enclosure or raceway is subject to physical damage. The conductors shall be installed in rigid metal conduit, intermediate metal conduit, or Schedule 80 PVC or equivalent. And now to take a look at figure 5-2, which illustrates the methods of protecting conductors from physical damage. It's shown on the screen now. Conductors running through framing members must be protected. A. Holes bored through framing members must be at least 1 1/4 inch from the edge of the member. B. Notches must be covered by a metal plate to protect conductors from nails and screws. And C. Guard strips must be at least as high as the cable they protect. Rules for buried conductors. Conduit, cables, and other raceways that are buried must meet specific criteria. The conductors must be protected so that damage does not occur. Table 300.5 of the code lists the minimum burial depth for conductors 600 volts nominal or less. The table in figure 5-3 shown on the screen is a condensed version of table 300.5. Deeper burial is not uncommon. Deeper burial is not uncommon due to soil conditions, interferences with other utilities, and structural footings. Cable under buildings must be installed in raceway, and the raceway must extend past the exterior walls of the building. Further, where buried conductors and cables emerge from the ground, protection must be provided by raceways that extend from the minimum covered distance to at least 8 foot above grade or to the point of entry into a building. See figure 5-4 to see an example of this. At the point where the underground conductors emerge from a raceway, the raceway should be fitted with a bushing or sealed. Regardless of the methods of wiring used, all underground installations must be grounded and bonded as required by the code. Refer to Chapter 10 of this text and Article 250, Grounding of the Code. Splices and taps are permitted in buried conductors and cables. Be sure to use materials that are suitable for underground use. All splicing materials must be suitable for the conditions and environment in which they are installed. Securing and supporting wiring systems. All wiring must be secured to and supported by structural members. Normally, wiring systems are not used to support other wiring systems or non-electric equipment. However, Section 300.11b of the Code specifies some conditions under which one raceway can be supported by another raceway. Mechanical and electrical continuity is required. Metal conduit, cable sheaths, cable armor, and non-metallic raceway must be continuous between boxes, enclosures, fittings, and cabinets. All connections between the components must be secure prior to pulling conductors. The equipment grounding conductor should be independent of the device connection. So if the device is removed, continuity is not interrupted. Conductor supports in vertical raceway. In buildings where raceways are run vertically, the conductors must be supported at assigned intervals. One cable support at the top of the raceway run and at intervals indicated in the table 5-5 are required. This table is a condensed version of table 300.19a from the code. NEC NOTE 300.19c3 when the cable is supported by bending it at least 90 degrees in a junction box and securing it with tie wires. Support intervals cannot exceed 20% of the normal maximum support distance. The bend in the conductor must extend horizontally at least twice the diameter of the cable. Support of vertical conductors can be accomplished in several ways, including the following. Placing insulated wedges between the cable and the inside wall of the raceway or using insulated clamps within an enclosure. Second is to install junction boxes with supports installed and attached to the cable, such as the one in figure 5-6 on the screen now. Third is to install junction boxes and offset the cable at least 90% and using tie wires within the box. Wiring within air handling spaces. No wiring is permitted within air handling ducts used for the purpose of transporting dust, flammable vapors, or cooking equipment ventilation. And plenums used for environmental air only. Wiring methods employing type MI or MC cable are permitted. Flexible metal conduit and liquid tight flexible metal conduit are also permitted in short lengths no more than 4 feet to connect sensors, louvers, and other devices permitted in these plenums. For other types of air handling ducts, refer to the code section 300.22c and the local inspection authority, which may have special requirements applicable to the specific conditions. NEC NOTE 590.3b temporary electrical power and lighting for holiday decoration and similar purposes is allowed for a period of 90 days or less. Temporary installations. The provisions of Article 590 of the Code are specifically tailored to apply to temporary electrical wiring methods, which may be less exacting than permanent wiring system. Temporary wiring installations are allowed for the purpose of providing power and lighting to facilities during construction. Temporary wiring can also be used for testing, experimental, and developmental purposes. Upon completion of the activity, the temporary lighting must be removed. Bear in mind that Article 590 simply modifies the code requirements, and that except for those specifically modified under that article, all other requirements of the code apply. Some of the modifications and specific requirements for temporary wiring are as follows. First, all lamps for general lighting will be protected from breakage by a guard over or around the lamp holder. Second, splices in conductors do not require junction or splice boxes if the conductors are part of a multi-conductor cable or open conductors. Third, ground fault circuit interrupters are required for all 125 volt single phase 15 or 20 amp receptacles that are not fed from a permanent wiring circuit. And fourth, regularly scheduled maintenance checks will be performed on equipment grounding conductors. The checks will be performed at no more than 3-month interval and will verify continuity, any damaged condition, and proper polarity relative to the grounding electrode conductor. Wiring methods. There are 3 broad classes of wiring methods: cable, raceways, and cable trays. Those are again cable, raceways, and cable trays. All of the methods are used to connect power supply or to connect the power supply devices and switches in an electrical circuit. Cable consists of several conductors wrapped by flexible outer covering. Raceways are enclosures installed between equipment or devices that are to be connected by conductors. The conductors or cables are placed inside the raceway, which protects and supports the wiring. Unlike raceways, cable trays are not enclosed. They are simply trays on which cables are laid. Multi-conductor cable. Multi-conductor cables are flexible assemblies of conductors having an overall protective covering. There are essentially four major types of multi-conductor cable assemblies. Shown on the screen are a few: service entrance cable, armored cable, non-metallic sheathed cable, and metal clad cable. Again, those are the main 4. Service entrance cable, that's SE or USE and ASE. Service entrance cable has conductors that can be used not only for service entrance wiring but also for indoor applications. Type SE, as shown in figure 5-7, is unarmored, moisture resistant, and flame retardant. It can be composed of 2 or 3 insulated conductors and an additional bare conductor. It is readily available in AWG sizes, 12 AWG through 4/0 AWG. Type USC is basically the same as type SC, except the outer jacketing is better suited for direct burial. It is highly moisture and corrosion resistant. Type ASE has an armored jacket which provides additional protection. As already noted, the service entrance cable is used for interior wiring or for service entrance cable between the utility supply and main service disconnect. When it is used for interior wiring, the grounded neutral conductor must be insulated, with the following exceptions. 1. When used as a feeder between 2 buildings, and 2. When used as the circuit conductor or branch wiring to a clothes dryer, counter-mounted cooktop, range, or oven. Service entrance cable may not be used for interior wiring of buildings of any type exceeding 3 stories high. Armored cable, AC and ACL. Type AC or ACL, often called BX cable, is used in both dry and wet locations, but is not permitted to be buried. See figure 5-8. This type of cable, once commonly used in many applications, has some limitations for commercial use. It may not be used in places of assembly, studios, movie theaters, hazardous locations, commercial garages, areas with vapors and corrosive agents, lifts, cranes, hoists, elevators, or battery rooms. Armored cable can be used in the following situations. See on your screen. First, as flexible connections to motors or vibrating equipment up to 24 inches in length. Second, as fixture whips up to 6 feet in length. Third, as in dry locations. Fourth, concealed behind walls, may be finished behind walls in old work. Fifth, exposed along wall surfaces. And sixth, where exposed to weather or moisture, type ACL only. Armored cable must be properly supported at intervals between 4 foot 6 inches, between intervals of 4 feet 6 inches, and within a 12-inch of terminal boxes or fittings. When routing BX cable through wall, floor, or ceiling members, the member must be drilled through the center or notched and covered with a metal plate to protect the cable from nails. The cable can be run along the sides of the studs, joists, or rafters without further protection. Guard strips made of 1x1 or 1x2 stock are used to protect BX or AC cable when it is run along attic floor joists. Caution: anti-short insulating bushings must be placed between conductors and the outer armor wherever the cable is cut. The bushings protect the conductor insulation from any sharp edges on the cut armor. Non-metallic sheathed cable, NM, NMC, and UF. Often referred to as Romex, non-metallic sheathed cable is frequently used as the preferred wiring method in small commercial establishments, as well as residential structures. This cable is made up of 2 to 4 insulated conductors plus a green insulated or bare grounding conductor with an overall non-metallic sheath. See figure 5-9 on this. Which is shown on the screen now. Type NM is used strictly indoors, while types NMC and UF are suitable for either indoor or outdoor applications. Further, type UF can be directly buried in the ground. Non-metallic cable must be supported every 4 foot 6 inches and within 12 inches of a terminal box, junction box, outlet, or fitting. It may be installed alongside or through studs, joists, rafters, and other building members with the same protection requirements and restrictions as with armored cable. This type of cable may also be installed in unfinished basements, attics, and crawl spaces, and it may be terminated in metal or non-metallic boxes. Metal clad cable, or MC. This type of cable is heavy-duty commercial and industrial assembly. Is a heavy-duty commercial and industrial assembly consisting of one or more conductors individually insulated and enclosed in an interlocked metallic armor that consists of corrugated tubing or interlocking tape. This type of cable looks similar to armored cable or BX MC cable is available in sizes 14 AWG up to 1000 kc mils. Its use is permitted in a wide range of applications. First, indoors or outdoors. Second, exposed or concealed. Third, for direct burial. Fourth, as open run cable in a raceway or a conduit tray. Fifth, as aerial cable on a messenger wire. Sixth, in hazardous locations. Seventh, in wet and dry locations. Eighth, for feeders, branch circuits, and service conductors. And ninth, for power, control, lighting, and other circuit applications. Type MC cable cannot be used in destructive corrosive environments, such as buried in concrete or earth that exposes the cable to harmful chemicals and contaminants. Raceways. A wiring method using raceways is more secure and safe than a method using only cables. This is a result of the added protection provided by the raceway. Unfortunately, a method using raceways is also more expensive. There are many different types of raceway. The selection of a particular type depends on the specific application. NEC NOTE 100 raceway is an enclosed channel of metal or non-metallic materials designed expressly for holding wires, cables, or busbars with additional functions as permitted in this code. Another NEC note. Additional information and requirements concerning the design and use of wireways can be found under Article 376 and Article 378 of the Code. Some key points within this article include the following. Wireways are not to be installed where subject to damage. Wireways are not to be placed in corrosive environments. Wireways are not to be concealed. And wireways are normally restricted to no more than 30 current carrying conductors. More than 30 current carrying conductors can be contained in a wireway if the ampacity rating is derated per section 310.15b3a of the code. NEC NOTE 376.22b and 378.22. Conductors for signaling circuits or controller conductors between a motor and its starter and used only for starting duty shall not be considered as current carrying conductors. Auxiliary gutters, essentially identical in construction and appearance to wireways. Auxiliary gutters are primarily used to extend or supplement wiring spaces at load centers, transformers, and metering cabinets. Auxiliary gutters cannot extend beyond 30 feet from the equipment they supplement. The same rules regarding fill 20% and splices or taps 75% apply as with wireways. Busways. Busways are sheet metal enclosures into which conductors are installed at factory. These conductors, which are actually copper or aluminum busbars, are supported by insulating material. Busways commonly come up to 10-foot sections and are bolted together when installed horizontally. Busways require supports every 5 foot unless otherwise designated. Busway systems are often used in commercial buildings as their primary wiring method. There are 3 types of busways available: feeder busways, plug-in busways, and trolley busways. A plug-in busway is illustrated in figure 5-19. Although the initial cost of busway material is higher than the other wiring methods, the installation labor costs are much lower. This often makes it a more cost-effective system. There are numerous wiring methods that are permitted for use with busways and taps or branch circuits: rigid nonmetallic conduit or PVC, electrical nonmetallic tubing (ENT), intermediate metal conduit or IMC, electrical metallic tubing (EMT), flexible metal conduit, rigid metal conduit, armored cable or AC, and surface metal raceway. Overcurrent protection. Overcurrent protection of busways is required at the supply end. If a smaller busway is tapped from a larger busway, overcurrent protection at the tap point should protect the smaller busway. An exception allows a short tap, 50 feet or less, with an ampere rating of at least 1/3 that of the overcurrent device protecting the larger busway, to be exempt from the required overcurrent protection at the tap point. This is a very important point, so let's repeat it. Overcurrent protection of busways is required at the supply end. If a smaller busway is tapped from a larger busway, overcurrent protection at the tap point should protect the smaller busway. An exception allows a short tap, 50 foot or less, with an ampere rating of at least 1/3 that of the overcurrent device protecting the larger busway, to be exempt from the required overcurrent protection at the tap point. Further information and the requirements concerning busways can be found in Article 368 of the Code. Caution: busways must not be used where subject to mechanical or physical damage, where there are corrosive surroundings, such as in battery rooms, where it is damp or wet, where there are explosive gases or vapors, where there is ignitable dust or fibers, where embedded in concrete, underground, in any outdoor or hazardous area, except where expressly approved for the purpose. Cable trays. Cable trays are open cable supporting assemblies used in a variety of commercial and industrial buildings. Cable trays are not enclosed, so they do not fit the description of raceways, but they have the same function. Tray systems are fully recognized as an approved method of wiring. Cable trays resemble troughs, open at the top, although covers are often used, with ventilated bottom sections. Figure 5-20 shows an example of a cable tray. There are two main types of cable trays, the trough and the ladder type. There are many specific rules regarding the types of wire and cable tray and cable that can be used in a tray system. Again, there are specific rules regarding the types of wire and cable that can be used in a tray system and how those wires and cables must be arranged within the tray. Article 392 of the Code permits trays to be used as a support system for wiring methods that can be used without a tray. Uses permitted and not permitted are as follows. First is where single conductor building wire is used in a tray, only size 1/0 AWG or larger, is permitted and must be marked as suitable for tray installation. Further, this only applies for two industrial installations. Only multi-conductor cable is permitted in a tray within commercial premises. Second, a metallic cable tray is acceptable as the equipment ground conductor for the circuits within the tray. Third, non-metallic cable trays are permitted in areas where there are corrosive conditions. Fourth, multi-conductor cables rated 600 volts or less may be placed in the same cable tray. Tray cable rated over 600 volts can be placed in the same tray with cables rated under 600 volts if a non-combustible barrier is installed to separate the high and low voltage cables. Cables within a cable tray can be spliced. Single conductor cable can be used only if multi-conductor cable is not available. Multi-outlet assemblies. The code addresses multi-outlet assemblies in Article 380. Essentially, these are two-piece assemblies. The top piece or cover is pre-punched to accept receptacles at close 6 inches and up intervals. The receptacles can be factory installed. This method of wiring is particularly useful and commonly found in laboratories, workshops, stores, schools, and offices, and it is installed exposed on the surface like other surface raceway. It may pass through walls provided there is no receptacle within the partition, and the covers on either side can be easily removed. And these are the review questions for the chapter. Most of the answers are provided. Do go through those, and If you have any doubts, questions, go through the material, not only of this video, but the text, which will be provided in the end of this video. Again, do review the material if needed. If you need to verify any of these questions or answers, do go back through the material and verify. Also, using the NEC section is very important to complete and become familiar with. It is a critical area in this course that basically helps you become familiar with using and learning about the various subjects within the NEC, that is the National Electric Code. This is the end of the lesson. Thank you very much, and here are the credits.